Good morning. Welcome to another episode 53 of... No, wrong button. Ah. I don't know if you can hear that.
But with curling noise, I might pick
My name is Dan Schiffman. I'm here live from the School for Poetic Computation on a Tuesday morning, July 22nd, perhaps? I don't know. It's 10:45 a.m. where I am. I'm here to do some programming, to talk about
this is like
rainbows and unicorns and all sorts of stuff. I've got a new song on my soundboard with wherever you need to think about random numbers. I'm going to do a coding challenge today, which will involve programming in JavaScript, which means I don't ever want to forget. This dot. Sorry, I'm a little too excited about sort of getting the soundboard thing going. I'm still not all the way where I hope to be at some point. But anyway, let me quickly give some introductions. My name is Dan Schiffman. This is Coding Rainbow. I already said all this stuff. If you are watching this as an archived video on YouTube, go ahead and look at this video's description if you want to skip ahead and find the time codes to where actual tutorials and programming things happen. What else did I want to say? Okay, so I have this, as you all know, I'm working on beating my record. Right now it usually takes me about 30 minutes before I actually start doing anything. Today I'm looking to make that happen within at least 15 minutes. Let me just give you a little bit of background here in case you are new. If you can always go to codingrainbow.com. That's the URL. There is where you can subscribe on YouTube. If you want to join the Slack channel, you can become a patron on Patreon. And if you just want to get emails sent out to you when I'm going to do a live stream, which I've been doing once or twice per week, you can put your email in there. There are only 3 days left to get your Coding Rainbow t-shirt. It is 3 days. The last date is July 29th, which also happens to be my birthday. This Friday, I will be at some age which has a number which has a 4 and a 3 in it. You can guess what number that is. And I think that's right. Anyway, you can get pink and blue and green, and you can also get some kid sizes as well. If you have any babies, you want to give them a Coding Rainbow onesie. Okay, so that's my... yeah, I was going to say, what number is my birthday? My age will be...
9, 2, 7, 6, 1, 9.
I'm waiting for a 4 and a 3.
9, 2, 1, 3. I think that.
3?
2, 3, 4.
Ah, 4. There we go. Okay. What is going to happen today? So one thing I should mention is one thing that I do is I am with the help of Mathieu. After I do a long session, like last week, I believe it was last week, I did a 3-hour session on genetic algorithms. Though it was on Friday, actually. And then usually what we do is we take and edit the videos. I can't. What happened to me? I've completely lost the ability to talk. Hold on a second. Hello. I'm back. I put my brain back in. So usually what happens after a long session is then smaller, shorter tutorial videos are edited out of that longer session. But those tutorials have not arrived yet. They will be coming a little late this time around, but I'm just going to dive right in and do another live session. I need coffee. No, trust me, coffee, not a good thing for me. Although actually I do drink coffee again, but there was for a while I didn't drink coffee. So let me talk about there's 3 things I want to do today. One is I want to finish up my discussion on genetic algorithms. I'm going to pick off where I last left off in the last Coding Rainbow session on Friday. So I want to do 3 more genetic algorithm examples. One of which I will do as a coding challenge. I'll program the whole thing from scratch, which I think, based on feedback, people have enjoyed that. So that's one thing I'm going to do today. The other thing I would like to do is talk a little bit about machine learning and neural networks, which I am planning to dive into on a future Coding Rainbow. And I just want to give you some thoughts and resources of things that I'm reading and researching in preparation of making some examples. So if you want to kind of read some of those things too and give me your feedback, I want to talk about that. And then I want to experiment with something. So I have a pro CodePen account now. CodePen has something called Professor Mode, and I had a Twitter conversation, an email conversation with CodePen that they opened up my account to allow up to like 100 people, I think, to live follow the code. So what I'm going to do is maybe we should just try this right now. So I'm going to open up a browser, and I'm going to go to CodePen. Is it codepen.org? It's not codepen.org. It's codepen.com. I'm going to log in. Uh-oh. Uh-oh. Dun. Uh-oh. Nope. I don't know my username or password. I do have it on I have it on this other computer. Hold on.
So this is random, this is noise.
I was just trying to give you some music to listen to. Okay. I'm looking for, on this computer, I have one password, and I'm looking for CodePen. And I see what my username is. Oops! Hold on, everybody. Got it. SHIFFMAN and oh, look at this. Look at this lovely pen of rain. I love this. Very nice. Okay, so let's see if we can make this work. I can't. There we go.
I always forget the this dot, this dot, this dot, this dot. I'm going to do this dot, this
Which
dot.
song is that? Which button is that?
This
W.
dot,
Okay.
this dot.
Okay, so here we are. Let's see if we can make this work. I should have looked at this in advance, but I'm going to make a new pen. I'm going to call it Coding Rainbow Test. And then now, how do I turn this into professor mode? Anybody have any ideas? Settings? Change view? No. Save? Maybe if you all just go to this link, it will just work. All right, in the chat, go to this link, codepen.io/shiftman/pen, capital J, capital K, lowercase k, DPM. See if you can go to that link. And see if you can see it. Should have looked at this in advance. Nuno writes in the chat, should have looked at this in advance, the most repeated phrase in CR. Thank you, Oliver, for posting that into the chat. It appears to work. So are you seeing, okay, so are you seeing, hold on. Do you see this live typing as I type it on your screen? If that happens, that will be so magical. I'm wondering, I'm waiting. Yes! So the only problem is, if you're watching this as an archive, you won't be able to see this. But this, I think, is a very exciting development, because what this means, what I can do is just use this periodically to demonstrate a concept, an HTML, CSS, or JavaScript web programming concept, and you can actually have the code and follow along. So what happens? Oh, you don't see that live. You just see if I hit save, does it update? Or you have to hit refresh? Reload is needed. Okay, so okay, timeout. I got to go to professor mode somehow. Maybe my account, let's just check and see. Settings, account. Thank you for being a pro. I have a pro account. GitHub, Twitter. I'm looking for, has anybody used professor mode? All right, hold on. You have got to change view. Oh, Arno is there. So Arno, I know, has used this. So I've got to change view. Okay. Change view drop down. Okay. I'm a little bit, change view. There we go, look at this. Dun 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 dun. Make way. I don't know. I'm singing songs from Aladdin all of a sudden. That's a little bit weird. Uh-oh. Okay, so change that. Okay, so now students watching 0. Now how do the students find the URL to go to? Okay, I just have to add /professor. What if does the student, do you just go to this view? Do you just go to the /professor? That's what I would like to know. Okay, and now more typing and testing. And, ooh, 2 students watching, that's good, console. Ooh, look at that. And how do I get the JavaScript code to run? 11 students watching. Whoa. Okay, let's see here. Look, you can chat with me there too. Okay, great. Okay, so this is working. Maybe let's do something with this right now. Actually, let's do a tutorial of how to use P5.js with CodePen. How about that, huh? Why not? That's been I feel like that's on my... So by the way, I didn't go through all the things I usually go through at the beginning of these live streams because I'm a little bit tired of doing that. But if you are wondering where you can suggest topics or follow along with a list of topics that I'm planning to do, yes, that's right. Okay, so the stream has about a 15-second delay on it. So you're going to see the CodePen stuff change. Greg points out a great point. You're going to see that in advance of me talk about it. So weird time warp thing is happening. But if you are interested, you can follow along with and suggest topics here in this GitHub repository. Okay, I now am going to search for, ooh, look at this, random pool selection. Interesting, there's new things. I'm going to search for CodePen. I feel like that is discussed. Ooh, maybe it's not. This seems like magic. Okay, let's look at this link. Oh, I looked at this. I think it doesn't. I think it's broke. Okay, so let's create an issue. How to use P5.js in CodePen, and I'm going to do this right now, just to keep track of it. Okay, so here we go. I have to admit something. I have seen CodePen. I'm aware of CodePen. I'm a fan of CodePen. I don't know that I've ever actually really made anything in CodePen before, but I feel somewhat confident that we can work this out. Here's a question that I have. Okay, so let's just do this tutorial. I can do this. So I'm in professor mode right now. If I hit Command S, fork settings, how can I minimize CSS? Ah, great. Minimize HTML. Ah, great. Okay. Okay, great. So sorry, I'm just save and close. Oh, look at this. So look at this. I was going to just add a reference to P5.js in the HTML file, but it looks like I can actually just put them here. Quick add. And is P5.js an option here? No, but that's okay. Okay. So save and close. So let's try that. Now I want to how do I want it to go back to its normal, how do I tidy, maximize? No. Oop. Interesting. I'm getting used to the interface here. Okay. All right. Let me make a new. Oh wait, no, I shouldn't make a new one. Can I just refresh this page and have it? I guess it's using my. Ah, there we go. Okay. Because this is what you will see most likely when you first start up. Okay. I'm going to do a quick tutorial about CodePen. And I'm going to do that before I go to genetic algorithms. Okay. Okay, here we go. 28 students are watching this live. Okay. Now, I think I'm standing in front of I'm going to move this a little bit over here. Where's the, console? We can see that there. Okay, assets, interesting. Okay. And let's make this a little wider. Change view. Change view. I guess that's sort of like the minimum. Can I go like this? Yeah, that's fine. I don't need my face there, so let's do that. Okay, sorry about this. 15 minutes in, I'm going to actually start doing something. I'm going to drink a little water here. And, okay, here we go. Here we go. Hello, welcome to a P5JS video tutorial about how to use CodePen with P5JS. Now, CodePen is a web browser-based code editor. It allows you to type some HTML stuff in this box here. It allows you to type some CSS stuff in this box over there. And then in that box on the end that I can't reach because my arms will get cut off, you can type some JavaScript stuff. So there's a lot to CodePen. I'm sure there's a lot of features. You might be watching this as an archive video, but I'm actually doing this as a live stream. And I'm using something called CodePen Professor Mode. And there are 27 people watching me live code this right now at this very moment. But what I want to do is just make a quick P5JS sketch and see how it works with CodePen and some of the features of CodePen that I might discover along the way. Because I actually haven't really used CodePen before. I'm discovering this as I make this tutorial. Okay, so first thing we want to do is, let's look under settings here, and I want to go under JavaScript. So one thing that I want to do is I want to make available the P5JS JavaScript libraries. Now, I could add references to those in the HTML file, but since CodePen has this feature, I can actually just add a URL to my JavaScript library right here. And now, how do I find the P5JS JavaScript library? It just so happens that if I Google CDN, CDN, by the way, stands for Content Delivery Network because it's going to deliver, it's a network that will deliver our content, the content in this case being the P5JS library. And I'm going to do this, CDN P5JS, and we're going to come to this URL, which is cdnjs.com/library/P5JS. And now I'm going to see a whole bunch of URLs. Now, one that I want right here for the main P5JS library is this one. So I'm going to grab that, I'm going to copy it, and I'm going to go back to CodePen, and I'm going to place it in here. And then I'm going to add another, while I'm here, I might as well let's add the DOM library as well. So I'm going to get the DOM library, and I'm going to put that in here. And then hopefully I'm going to save and close. And now, if I go back to settings, we should see that these files are referenced. And incidentally, popular JavaScript libraries that you might use are available directly right here. So if I wanted to use jQuery for whatever reason, I could just kind of go into this menu here. Okay, yay! Oh, ow, I have a giant pimple on my nose, and I just whacked it. It hurts. I don't know, if you zoom into the pixels, this is going to be permanently in this video forever now. But you can zoom in and try to find it. It's very, it's quite noticeable. Okay, save and close. Maybe I'll edit that out. I won't edit that out. It's just there. Okay, so now let's just see. So one thing I'm going to do is, I don't really care about CSS or HTML right now. I mean, I care about them. CSS and HTML, I care about you. But right now, they're not the primary focus. I just want to see if things are working. I'm going to add function setup. I'm going to say create canvas, 200, 200. I'm going to say background 0, and I'm going to hit save. And look at that. There, P5JS sketch running in CodePen. I don't know, what else should we do in this tutorial? I didn't come up with something to make. Let's just make sure things animate. I'm going to add function draw. And I'm going to say ellipse, mouse X, mouse Y, 16, 16. I'm going to hit save. I hit Command S, by the way, to save. And you can see now there is my sketch running. I could also add something like create P, which is part of P5 DOM. And I could say, this is a sketch. This is a painting sketch. And I'm going to hit Command S again, and you can see now there I have a paragraph element there. We could add something like, let's see, a print line test. Actually, let's add the mouse pressed function. Somebody in the chat is mentioning that create P sounds like something else. I guess that's true. Print line mouse X. So I want to look at the console. There's a console here, and I can click. And every time I click, you'll see this is very hard for you to see. So let's zoom in on this. You can see that I also have access to a console right here in CodePen. This is lovely to use. I love CodePen, I'm enjoying it quite well. Look, there's a chat here. Look, people are talking in the chat because they're watching this live. And I am also going to say change view. And I can now oh, look at this. So you can see one of the nice things is there are different views here. So if I want to go to presentation or full page, I could click on that, or I could also just go up to the URL and type full here. And now you can see there's my sketch. So this is actually how you make a P5 sketch in CodePen. It was really quite easy. And I wish I had prepared to do some other stuff in this video. I'm going to just pause, and maybe this video will continue in a second where I do some more stuff. Alvaro, every once in a while I check out the chat. And maybe it's okay just to have you know what? I think it's fine. But I'm back, and I've decided that it's okay to have a very short, just like 5-minute video that showed you very quickly how to use P5JS in CodePen. So if I'm going to do this in future videos, if you have questions about it or features you want me to explore, please let me know in the comments or at the Rainbow Topics GitHub repository that is also linked to in the description of this video. Thanks for watching. Yeah, so tell me, so if you guys interact with the sketch, let me ask you a question. So I'm going to go back to professor mode. Professor mode, I guess, is fine as a name. Okay, so let's say let's say you've now messed with the sketch and you've made it do something totally different. But I do this. What happens to your changes if I suddenly hit save? Does it just override what you did? How does that work? And it updates automatically. Like, does it keep your changes? Like, if you add something to setup and I change something in draw, do you get my change but keep your change? You can't edit the code. Please clear canvas in the beginning of the loop. This seems overwrites. Okay. So that's fine. You can play along and follow along, but whatever I do overwrites. Okay. All right, well, that was exciting. So if you pause, you can edit. Got it. And then when you play again. OK, so that's interesting. So I assume this would be useful for future coding challenges for you guys. One thing I'm having difficulty that I need to think about is how to arrange my screen. This is not a huge area for me to type code in. So I might sort of look into some of the layout features here of CodePen. Which I think could be useful. But I'm gonna look into that later. Okay, so I'm gonna save this. I'm gonna go out of here, and I am going to. So what I want to do is I don't want to go out of there, because I want to go to Rainbow Topics, and I want to sort all the issues by most thumbs up. And I want to go to genetic algorithms. OK, so this is what I'm working on now. And OK, so update this. So if I recall correctly, this is what I got to last week on Coding Rainbow. So I went over the basics of a genetic algorithm, what it is, why it exists. I went over the core algorithm step by step. I talked through this Shakespeare monkey problem. One thing I really forgot to say, which is I really wish I had, and I'll make sure this is in the video descriptions, is The Shakespeare monkey problem, the inspiration from that comes from Computational Beauty of Nature. So this is a wonderful book. I will just by Gary William Flake, called The Computational Beauty of Nature. My book, The Nature of Code, a lot of the ideas from that book come out of having read this book. So you know, a lot of credit should go to that book. And I believe in this book, the Shakespeare monkey problem is discussed at length as well. And you know, honestly, I don't specifically recall, but I assume that's where the idea originally came to be, because it was like, I think in 2002, I worked on a project which was a distributed piece of software, kind of like, I don't know if SETI at home still exists. You guys know about it's the Search for Extraterrestrial Intelligence, SETI, S-E-T-I. There was like, there's massive amounts of audio and radio wave data that's collected from various things pointed at space. And so there's a piece of software that you could download and run on your computer that would analyze and look for signs of extraterrestrial life, and was distributed, and everybody could run it on their computers, or contributed to a centralized database. This was like a thing. Maybe it's still a thing now, but I was into that, and I made my own software that just like recreated the entire works of William Shakespeare with random typing monkeys in a distributed way. Anyway, that was a long time ago. So look, synchronization with YouTube chat. I don't know what that means. So anyway, I went off on a tangent there, but so I just wanted to make sure that I referenced this book. Okay, back to my list. I want to dig up that. I think I made that software in a Macromedia Director, and I wrote the server in Java, old ancient technology. This is like 2001 or 2002. Right, my birthday has a 4 and a 3 in it. Did I mention that earlier today? Okay. So anyway, so back to this. So I have, in my head at least, 4 more video tutorials that I want to do today. And what I think would be worth doing is taking this forces and vectors tutorial and about making a genetic algorithm evolve an array of vectors, which describes a path in a window canvas, and actually do that as a coding challenge. And when I say do that as a coding challenge, I mean kind of write all the code for it, as opposed to just show the example and talk through how it works. So that, in the chat, let me know if that sounds like an interesting and good idea. I guess what I might do, what I could consider doing, is not writing everything from scratch, but by taking a vehicle example and taking a genetic algorithm example and combining the two and like copy pasting the code into something and then making it work. Maybe it's better just to write it from scratch. I don't know, we'll see. And then I also want to talk about interactive selection, ecosystem evolution, and also talk a bit about fitness functions. So that is my plan here on
Cutting Rainbow.
Okay, I must have. All right. Okay. So let's see here. So let me get set up here. As always, I always forget the this dot, this dot, this dot, this dot. I'm going to do this dot. So I'm going to use the Atom editor. This dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do dot, this dot, this dot, this dot, this dot, sorry. This dot. And what I'm going to do is create a new folder, Smart Rockets. This dot, never forget this dot, this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do dot, this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do this dot, this dot. This dot, son. This dot, this dot, this dot. Never forget this dot. This dot, this dot, this dot. Never forget this dot. I'm gonna do the this dot, this dot, this dot, this dot, the this dot song. Never forget the this dot. Somebody composed that song for me.
So this is random, this is noise.
Perlin noise, that is. In the core random algorithm, the actual random algorithm itself, those numbers aren't related at all. You pick, like, I'm picking random numbers between 0 and 10. 9, 2, 7,
6, 1, 9, 4, 8, 9, 2, 1, 3. I picked 9 a lot apparently. But with Perlin noise, I might pick numbers like this.
Okay.
2, 3, 4, 3, 4, 5, 6, 5, 4, 5, 6, 7, 5, 6, 7, 5, 6, 7, 8, 9, 8, 7, 6. Boy, this is like Perlin noise performance art.
I have a new fan.
9, 2, 7.
I wish I had long hair so I could could just be blowing in the wind here on my live stream here on YouTube. Okay.
2, 3, 4.
Okay, so this I can minimize.
Boy, this is like Perlin noise
and
performance
now I can
art.
open this up.
9, 2, 7, 6, 1, 9, 4, 8. But with Perlin noise, I might pick numbers like this. 2, 3, 4,
sketch.
3, 4, 5, 6, 5, 4, 5, 6, 7, 5, 6, 7, 5. Perlin noise, that is. Perlin noise. So this is Perlin noise, that is. Perlin noise. This is Perlin noise, that is. Perlin noise. So this is Perlin noise, that is. Perlin noise. Perlin noise, that is.
Also want
this is Perlin noise, that is. Perlin noise. This is Perlin noise, that is. Perlin noise. So this is Perlin noise, that is. Perlin noise.
Perlin noise, that is. Perlin noise. This is Perlin noise, that is. Perlin noise. This is Perlin noise, that is. Perlin noise.
I don't need the sound.
Perlin
Get rid of that.
This is Perlin noise, that is.
Okay.
This
I'm
is
just about ready. Okay, so
But with Perlin noise, I might pick numbers like this. 2, 3, 4, 3.
all right, so here's the question for you guys. I don't know if you've been thinking about it. There's basically 3 possibilities here. I could. I forget if I don't have the key mapping correct. I could. Whoa, I did this wrong again. I forgot I changed. Okay, it's fine. Ooh, look at that. Whoa, what did I just do? It faded between them. I don't know how I did that. I didn't have this ready to be erased. So there's a few possibilities here. I could program the entire thing from scratch. So I just start with no code whatsoever. I'm going to make a rocket object, a DNA object, a population object, write the algorithm in, just make everything entirely from scratch. That's option number 1. Option number 2 is I could start with example that I at least have a moving physics object, one of them, and then I do all the genetic algorithm stuff from scratch. And option 3 would be that I have, well, I guess there's 4 options. Options 3 would be that I start with my genetic algorithm example and add all the physics stuff. So I could start with physics, add all the genetic algorithm. I could start with my genetic algorithm example, add all the physics. Or I could start with a physics example and a genetic algorithm example and combine the 2. From scratch. Everybody loves the from scratch. I'm very happy to do it from scratch. I think that's kind of fun and crazy. All right, so it's one thing. I had somebody from YouTube contacted me for a free consultation on my YouTube channel, which was very exciting. And one of the things they told me with looking at my analytics and statistics was the coding challenges are quite popular. And people seem to really like that. Everybody in the chat is just saying from scratch. All right, so that's what we're going to do. Smart rockets. What I want to do, whoops, I don't know. I want to look up. There we go. So we're going to start with this. This is a project. Can we find a date on this? This is by J.R. Thorpe. I feel like I want to tweet that I'm about to do this live, but it's fine because J.R. will be excited to know. But I will just mention it to him later. So let me hit OK here. So this has got a lot of fancy stuff in it, in that the rockets are, you can't really see, but they have like a nice design, and they're shooting little like blasts out of their. But wait, hold on. I'm sorry, everybody. I left to put my brain back on. Okay, so this is a project called Smart Rockets. It's by J.R. Thorpe. It was created many years ago in a programming environment called Flash. Whenever I say Flash, I like to say Flash. I need that as a sound drop so I could just say, except that didn't work. Sorry. Sorry, I don't have I'm not good with the key commands yet. Okay. I like that, Mathieu. Mathieu says, presenting a multi-part video series on a subject and ending it with a coding challenge recapping is the best. Okay. Okay, so anyway, back. So this is created with Flash. And what it's doing here is that there are, I don't know how many rockets are on the screen. There's something like 20 rockets. And each rocket has a bunch of engines attached to it. And those engines, or thrusters, so to speak, fire a little burst of energy out the back. And those have a vector. Like, actually, you know what? I'm just going to make the video, and I'm going to talk about it in the video. So, Flash. I don't know, I can't use it. Okay. All right, so I'm just going to start. Okay. Here we go, everybody. I'm going to refresh this page. Oops. Okay. Here we go. Okay. Hello and welcome to another coding challenge. Now, in this coding challenge, I am going to program from scratch. I'm going to recreate this project called Smart Rockets. Now, this project, Smart Rockets, was created over the actual year, because I don't know what it is right now, at some point later, by J.R. Thorpe. This program was made in Flash, which is a programming thing, Adobe thing maybe, a Macromedia, who knows, some company, blah, blah, blah. That's another discussion for another time. I'm going to hit OK and let this run. But there's a genetic algorithm here where these rockets that at the moment don't look very smart are evolving a path, essentially, from the bottom of the window to that target up there. So let me talk through just very briefly how these rockets work. So in Jer's Smart Rockets example, here's a rocket. Hold on, timeout. Let me just start the whole thing over. This pen is no good, and I was gonna say I could just edit it from where, but you know, editing is so unnecessary. Let me try this pen. Okay, there we go. One is that. Two is it. It's backwards. I want to fix that, but I'll fix that another time. Okay. Start singing Flash. Oliver, I don't think I'm going to do this in CodePen, Oliver, because I'm just not super comfortable with the environment. I know that would be really useful. That would be really useful so you guys could follow it along. Let me do this one not in CodePen, and I'm going to practice with code, because this is going to be hard. And I'm going to practice in CodePen a little more, and I'll do some other stuff in CodePen. I know, sorry. Okay, here we go. Action script, yes. Okay, that's what I was looking for. That's the word I was looking for. I know you could help me debug. Oh, you guys are really getting me here. Okay, I'm gonna not do this. I know my limits, and I'm gonna do stuff. Future challenges will happen in CodePen. Practice is really fine. You guys talked me into it. Okay. Okay, let's see. New pen. So the question is, I need to figure out a few things. The question is, I need to save. Oh, nope, edit. Smart Rockets. This is the URL. If you guys, oh no, I'm not in whoa, this is the XKYBLP. Capital X, capital K, capital Y, lowercase b, capital L, capital P. Okay, so I'm going to change the view to professor mode. I am going to put in, I'm going to just give myself a bigger, I am going to go to settings, and I need the CDN links again, CDN.js. Let's get P5. By the way, I easily succumb to peer pressure, as you guys have just learned. JavaScript here, and then should be actually, oops. The DOM library is here. Should be able to go here. Save and close. I should be able to say function setup, create canvas, 640, 360, and function draw, background 0, save. That runs it. Okay, now what I would like to do is figure out how to very easily is there a way for me to make new JS files? So can I have multiple JavaScript files? That's something that I kind of need to do this. It's a big example. Anybody know? Add another resource? No. So it's going to be hard without multiple JavaScript files. And then also I want to change, I bet you editor layout. So this I can do. This is good. I like this. So I think I should do it this way. Yep. So this is good. And then let's just make it, yeah, that's good. And console pops up. Is this an interactive console? Like, interesting. Oh, yeah. I like that. Okay, well, I'm in front of the console. That's a bit of a problem. But I don't mind my head being in front of this so much. The other thing is the font size is a little bit small. So how do I change that? I guess I could just do this, but I think it would be better to change the font size settings. Anybody know where I changed the font size? Change view, direct code links. What's that do? Oh, look at that. Pen details view. You know, professor mode. Open on cross browser testing. What's that do? That's really cool. All right, I'm not going to worry about that right now. Oops, I lost it. History recently closed. Should be this one. Whoops. Sorry, everybody. Go to settings. You guys are telling me things in the chat, but I don't know what you're referring to. Minimize. Go to settings to change font size. I am pro. I'm pro. I'm not a pro. Settings. Where? Font size. Font size. Where? Code indentation. Ooh, spaces. 2 spaces. Auto save. Auto update preview. I don't see where I do the font size. Okay, profile pick. Okay, thank you. Settings. Thank you. Ooh, I like source code pro. I'll just leave it default though. Code font size. Let's try 18. Editor options, line number, cold folding, key bindings, normal, sublime. Auto update preview. Example. Okay, this notifications customize. Anything else I want to do? Apply the CSS, customize blog, default pen theme, iframes, images. I think that's going to be. Did that get bigger? I can't tell. I don't know that it did actually. Settings. Yeah. I must not have hit save. Save all settings. Okay, now go back to pens. No. How do I find mine? your profile. Smart Rockets. There we go. I go to Professor. Minimize. Minimize. There we go. The font size fixed. Okay. In your profiles where you have access to assets, you can pick typeface too. Yeah, the thing that I want to do is I want to be able to like, I want to be able to be like new. I just want to have like multiple, but you know what? I guess I'll do this in one big JavaScript file. It'll be more challenging, but yes, this is Rustbasket asks, this is what makes beginners hate programming, learning the environment instead of the actual thing. This is why my inclination was to not use CodePen, but also for debugging, I can, I should be able to do this. Great. Interestingly, how it's kind of interesting how it comes up here. This is interesting to use. Okay. Okay. All right, I'm going to go for it. Why not? I'm going to use CodePen live professor mode. The stuff will be above my head. The rockets will be moving around, and it's time to do this. Why not? Yes, I believe I can add files, but then, okay, so I can add files, but then can I edit them? Like, what if I, like I have assets here, scripts. Like, let's say I go, let's find, let's just as an example, let's say if I go here and take this mover.js and I drag it over here. So now I have that. So I have that asset. And what can I do with it? Like I can't just make that a thing that I edit over here, I don't think. So I'm going to delete this. Whiteboard showing a little. Okay. Okay, we're just going to go for it. Okay. You guys talked me into it, and here we go. Okay. All right. Whew. How's my hair? Can you see the giant pimple on my nose? It's very painful if I touch it. I don't know what happened. I thought I had a sunburn at first because it's so hot and sunny here in New York, and then I realized it's just a big pimple, which you wouldn't think happens at my age, but apparently it does. Okay, here we go. Flash. Okay. As always, I always forget the this dot, this dot, this dot, this dot. Ah, I pressed the wrong button. F Looper was in the chat, so F Looper, I made this sound drop.
9, 2, 7, 6, 1, 9.
Okay, here we go. And here we go back to here. And here we go. Try dragging the asset to the editors. Oliver, you always have a suggestion right when I'm about to. Does that really work? Okay, hold on. I swear I'm going to do this coding challenge. Let's try, let's see if I, so, okay. So, yay, what if I take this? I can't drag it anywhere. And then what if I go to settings, quick add? I think it's just something that I could reference in the HTML file. Okay, forget it. I'm just gonna have to do this in one file. Hold on. Now I want to delete that just in case it messes me up. I'll figure this out later. Here we go. There is an assets tab. I know there's an assets tab. Okay. Here we go. I got to get started with this. You guys are giving me good suggestions. I'm sorry. All right. Remember how I already started this like 20 minutes ago and then I decided I wanted to start it over? Okay. Here we go. Hello and welcome to another coding challenge. In this coding challenge, I am going to program from scratch something called Smart Rockets. Okay, what is this Smart Rockets thing? Well, this Smart Rockets project, which I have running behind me, you can find a link to it in this video's description, is something created by J.R. Thorpe some number of years ago. It's developed in Flash, which is a environment for programming ActionScript. I'm going to do this in JavaScript using the P5.js framework. The reason why I love this project is it's a great example of genetic algorithms in the wild at play with an animation physics-based system. So what you'll see here is that there are these rockets being launched from the bottom, and they're trying to reach that target up there. And they have built into them this DNA, this virtual DNA that tells them how to move about the screen. So let me briefly talk to you about how that works. So the rockets actually have a bunch of like kind of thrusters on them. This is my like pathetic, terrible drawing of that. And all of those point in a certain direction. So the number of thrusters and the direction that they point in is part of their DNA, and then the sequence by which they fire, first, second, third, fourth, is also part of their DNA. So you can imagine like if you had a control panel with 5 buttons on it, you could press those 5 buttons in some sort of sequence to try to push it in some efficient way to reach that target. So what I need is a couple things. I need to ultimately have a rocket object, and that rocket object is going to have physics built into it. I'm also going to need to have some DNA object, which is DNA to control the physics. And then the DNA object is going to need to have functions like mutation and crossover. These are pieces of functionality that exist as part of a genetic algorithm. Hey, if you want to know about genetic algorithms, I have a whole set of video tutorials linked to the description of this video that go through the algorithm in detail. I'm going to do that again in this video, but I'll be programming kind of quickly. So if you want the sort of longer explanation of that, go back and watch those videos. And then the third thing here is I'm going to need a population object. And the population object is going to manage an array of these rocket objects. So I'm going to make some rockets, let them go, have them evolve, let them go again, have them evolve, let them go again, and eventually they should make it from the bottom to the top. Maybe I could put some obstacles in their way, that sort of thing. Let's check on how these rockets are doing. You can see a kind of path that they're, by the way, the text Smart Rockets here is an obstacle, and they're trying to figure out how to get around it. So I'm going to leave this browser window open, hopefully. I won't forget to close it. And at the end of the video, we'll come back and check on how those Smart Rockets are doing. Now, I'm also going to do something a little bit crazy. It's not that crazy. I'm going to program this all using CodePen. I have already added the P5.js JavaScript files. You can check my video of how to do that in a different video. I've already added those, and I just started with basically nothing. I have create canvas and background. This is the only code I have. Create a canvas and draw a black background. So the first thing I want to do is create this rocket object. So I'm going to do that with a constructor function. And I want my rocket to have a position, and I'm going to say create vector. I want it to have a velocity. I'm going to say create vector. And I want it to have an acceleration, and I'm going to say create vector. Then, I'm not so used to using CodePen, so we'll see how this goes for me. I then also want to give it a function, an apply force function, where this rocket can receive a force, and that force would get added to its acceleration. That is Newton's law at play. And then I also want to, what else do I want to do? I want to have an update. Oh, and that should say this.applyForce equals function. I also want to have it have an update function, this.update equals function. And I want that function, I want to do the sort of standard physics algorithm that I do in a ton of my examples, where I have this.velocity add this.acceleration. And then I want to have this dot position, add this dot velocity. And then I also want to clear the acceleration at the end by multiplying it by 0. Because so the whole, this is like I just built a physics engine in like 10 seconds. Basically, I have an object that has a position, a velocity, and acceleration. Acceleration gets controlled by forces in the environment or forces by its rocket thrusters, so to speak. And the update function is where the physics actually happen. Okay, so I also want to have a function called this dot show. I'm just gonna be, my rocket won't be as pretty and beautiful as Jer's smart rocket. I'm just gonna say, I'm just gonna make a rectangle at this dot position dot x, this dot position dot y, and the rectangle will be thin but tall. And I'm also, actually what I'm gonna do is I'm gonna say translate. I wanna rotate it in the direction that it's moving. I think that'll be a useful thing to have. So I'm actually gonna translate to its position and then draw the rectangle at 0, 0. And I'm also gonna say rect mode center. And I am also going to say then rotate by this dot velocity dot heading. So the heading function in the P5 vector object gives you an angle of the direction that a vector is pointing. So I can rotate by the angle, the velocity being the direction that it's moving. I also want to add around this push and pop. And there, if I add push and pop around this function, then all this rotating and translating won't affect other things. So let's go now and see if I can create just a single rocket on the screen. I'm going to say a rocket equals new rocket, and then I'm going to say a rocket dot update and rocket dot show. Oh, look, there it is, the rocket in the top left. So one thing I want to do is I want my rockets to start at the bottom of the window. So we can see there it started there. And then let's just say for the sake of argument, I give it a velocity pointing up. Is it moving? Whoa, okay. So one thing you'll notice, I drew it vertically and the angle I'm getting is probably 90 degrees, so it rotated it. So I think I'll just change the way I draw the rectangle to be wide and tall. And you can see there, now I have a rocket moving up. So I have a single rocket. That's a good sign. I am getting something going here. Okay, I'm looking everywhere because I got a screen here, I got a camera here, I got a wall here. I'm going a little crazy here. Okay, this is good. This is good. Okay, now what I think I want to do is I'm going to create a population. You know, I don't necessarily need a whole separate object to manage this stuff, but I'm going to do it anyway. And in the population, I want to have an array of rockets. And I want to also have population size. We'll just make it like 100. And so, I'm sorry, I'm writing a little loop here. Can you guys see this font? I swear I made the font bigger. Time out, pause. I think this font size got smaller at some point. I'm gonna, let me just check that. No, it's at 18 point. Is the font size okay? Can you guys watching this on YouTube see it okay? Maybe I'll just make it a little bit bigger. Oops. You can see. I made it a little bigger. It seems small to me. Okay, fine. You guys are telling me it's fine. It looks so small to me over there, but you guys are seeing this maybe full screen. Anyway, I made it a little bigger. Okay. Back, I made the font size a little bigger so it'd be easier to see in the video. So what I want to say is this dot rockets index I equals a new rocket. And one thing I'm going to do is have their initial velocity, just for right now, be just so I can see a random vector. And what I'm going to do now is create a population. And I'm going to say the population should update. And I'm just going to actually write a function called run. And then in the population object itself, I'm going to write a function called run. And what I want to do there is, what's the, pause. What's the keyboard shortcut for auto format in CodePen? Somebody must know. Somebody must know. I'm waiting for the chat to catch up to me. Alt F4. So on a Mac, Alt would be Option. And do I probably have to do Option function? No. Command Q. Haha, very funny, Gregory. Shift Tab. There we go, Shift Tab. That seemed to kind of work. This is the other thing. I have Adam all set up to do this kind of stuff. Control K plus D. You guys are giving me a lot of funny business here. I think Shift Tab seemed right. Right? Yeah. I'm not used to hitting that. Okay. Okay, back again, and what I want to do is now say, oh, this dot rockets. Whoops. I need to say this dot rockets. Rockets index I dot update, and this dot rockets index I dot show. And let's see, there's an exclamation point here. So I'm just going to keep going with this video, and I realize I have a problem. So at some point, I think the sound went out. I was having trouble setting up CodePen. So there will be an edit point earlier, and now I'm picking back up. I'm picking back up here. Okay, so Chris Jordan is reporting some problems in the chat, but hopefully most people are seeing me in some sort of relative live-ish place. This dot, this dot, this dot, this dot's on. Okay. I'm back after some technical difficulties, and there's a big bug in my code. It's not missing a this dot, but it's almost as bad. Remember how I said here I need this function called pop? I need this function called pop to use push and pop to make it so that this translate and rotate only affects this particular rocket. Well, guess what I did? I made a variable named pop for population, and that variable pop is now my global variable, which overrides the p5 function named pop. So I really shouldn't have done that. I need to name this something else. I'll call it popule for population. And you know what? I don't know. I can actually just say population. I'll do this, population run. And now we should see, there's one rocket lifting off. And now I can change the population size to like 25. And we can see, there we go, a bunch of rockets all going off in their random direction. Let's clean up some things about these rockets. Let's make them a little bit smaller. Let's say no stroke. Let's give them fill 255 with a little bit of alpha. And we should see now, there we go. So these are our smart rockets lifting off from the bottom of the screen. So we're getting somewhere. We've got the physics system. Now, if I return to over here, in the original smart rockets, there are actually a set of specific thrusters positioned on the rocket that push off a force in a given direction. I'm going to do something a little bit simpler. What I'm going to do as the object's DNA is I'm just going to create an array. The array of DNA, the DNA is just going to be an array. And in each spot in that array will be a vector pointing in some, at first at least, some random direction. And what the rocket will do, it will read that array, each vector at a time, and apply that vector as a force. So let's look at how that might work. Press this button, here I am. Okay, so what I want to do now is create an object called DNA. And in that object, I'm going to create an array, and I'm going to call that array genes. And I'm also going to create like a length variable. And actually, I'm going to make this a global variable. I'm going to have a global variable just called lifespan. And let's make that 200 right now. Because I'm going to let each rocket live for 200 frames. And so its DNA needs to have an array of 200 vectors. It's going to apply a single vector each frame of animation. So, you know, so I'm going to, now what I'm going to do is I'm going to go from I to 0 to lifespan. And I'm going to, in that array, I'm going to give it a random vector. So what I'm going to do now is I want the velocity vector for each rocket to, to start off at 0. Come on, everybody. So we can see now here all of the objects just start at the bottom of the screen and they're not moving. But I'm going to give each rocket some DNA. And then in the update function, and then each rocket also needs a counter variable, this.count. And what I'm going to do in update is I'm going to say this.apply force, DNA.genes, this.count. And guess what? I forgot. This dot. So I need this.dna.genes index this.count. I know that's a mouthful of stuff, but I made a DNA object in the rocket. That DNA object has built into it an array called genes. It has 200 vectors in it, and each frame, what I want to do is apply one of those vectors as a force, and then I want to increase the count. So now we can see what, look at this. Let's run this again. You can see them going flying off like crazy. So those forces were rather large. So another thing I think I could possibly do in my DNA is I could just make the force a little bit weaker. And you can see, there we go. So here are the rockets kind of moving off, each getting a force. And I also want to look, I want to be able to see the kind of the lifespan itself. So what I'm going to do also is I'm going to say life p life p equals create p. I'm going to make a paragraph element, and then I'm going to and you know what? I just realized, even though it's nice to have the rockets have that count, I think I'll just make that count a global variable, because it's really going to be the same for everyone. So var count equals 0. And what I'm going to do is say life p.html count, and then count plus plus. So now you can see over here, right, I've got something showing me where we are. And now at some point, I'm going to go past the end of that array. I'm sure we're seeing some sort of error here. Count is not defined. OK, well, that's something else. Where am I getting that? This.count. That can go away. So at a certain point, I'm going to go past that array. But that is when the generation would end, and I'm going to reset the count back to 0. Ah, are you following me? I got lost in my own thought with all my computers and typing and coding thing. So here we are. And yes, here we are. We now have a system so far where I have a population of rockets. The rockets have DNA. The DNA has embedded into it an array of vectors that tell it how to move around the screen. Now, what I need is a target. I need to have a place where these rockets are trying to reach. So I'm going to create a variable called target, a global variable. And I'm going to say target equals create vector. And let's put it in the middle of the window at the top. And what I'm going to do also in draw is I'm going to just draw a nice little ellipse at target.x, target.y, 16, 16. And we should see that's where they're trying to get to. That's our target. And then what I want to do is I want to say here, if count equals lifespan, count plus plus, then I want to do something. I want to reset. Let me just reset count back equal to 0 right now. And as a little trick, I'm just going to do this, just to sort of see. This is not what we want to do, but I kind of want the whole thing to start over. I don't know the auto format in CodePen. OK, so now we should see when this gets to 200. So we've got the system working here. We have, and I'm just going to kind of zoom in on this to talk about it for a second. OK. So over here, we have a system now where I am every 200 frames launching 200 rockets into space. And I'm counting up to 200. And when I get to 200, I start 200 rockets over. What I'm missing now from this example is the genetic algorithm itself. Instead of just creating a completely new random population, I want to make a new population out of the rockets I want to make a new population from the previous population of rockets. I want them to create children rockets. I want the rockets with the highest fitness, that did the best, to pass on their genetic information to the next generation. Here we go. People are telling me that there's chat messages. I don't think I can handle looking at the CodePen chat. If you might be watching this as a YouTube archive, this is actually happening live with people watching the code on CodePen Live as well. Okay, so let's see here. What's the next step that I want to do? The next step that I need to do in population is, I'm going to say this dot evaluate. Uh-oh, my camera went off. So what do I want to do in evaluate? I want to run through all of the rockets, and I want to calculate their fitness. This dot rockets index I calculate fitness. So I need a new function in each rocket to calculate their fitness. So where's my rocket object? Somewhere here, right? I'm going to write a function now. This dot calc fitness equals a function. So what should their fitness be? Well, we could say that the closer a rocket makes it to the target, the more fit it is. So I can say var d equals distance, this dot pos dot x, this dot pos dot y, target dot x, target dot y. CodePen couldn't fit that all. It's not CodePen's fault, but I don't have enough room to fit that all in one line, which is why it broke off. But you can see I'm taking the distance. Now, the other thing I want to do, though, is say that, and let's give these rockets a variable called fitness. So, and I'm going to say this dot fitness equals 1 divided by distance, right? Because if the distance is 1, my fitness is 1. If the distance is 100, it's further away. My fitness should be lower, like 0.01, like 1 divided by 100. So in this sense, I now have a fitness of 1 divided by distance. Okay, this is good. So in the population, back to the population. It's hard to have everything in one file. I have now calculated the fitness. Now the other thing that I need to do, if you watch my previous genetic algorithm videos, is create a mating pool. I want to have a mating pool from which I can pick parents to create the next generation of rockets. And in order to pick the parents, I want their probability, the higher their fitness, I want the higher chance of picking them. So rockets that did really well or that get closer to the target are more likely to pass their genetic information down to the next generation. So what I want to do is create a variable. I'm going to call it a mating pool. And it's an empty array. And the first thing I want to do, actually, I need to make sure I clear it. So every time I do this, I want to make it an empty array again. And then what I want to do is I want to normalize all of the fitness values. I think this would be useful to do. I want them all. I guess they're all going to already be between 0 and 1 though. Because I guess if it gets closer than 1 pixel, boy, there's some things. There's a lot of things to think about, and add. Why not negative of the distance? Oh, that's an interesting idea that Oliver. So we could try that. Let's be. You know what? I want to use positive numbers because. The way I'm going to add things to the mating pool, I think that'll be, but that's an interesting idea that I could explore. But let me actually do something to normalize the fitness values. So one thing I want to do is, while I'm calculating the fitness, I want to do max fit. And the maximum fitness is 0. And if this dot rockets index I dot max fit is greater than max fit, and this dot rockets fitness is greater than max fit, then I want max fit to equal that particular rocket's fitness. So I want to find the maximum fitness. What's the highest fitness out of all of the elements? And then after I do that, I want to go through them all again and I want to take their fitness value and divide it by the maximum fitness. So that should normalize them, right? If the maximum fitness is 1,000, the one with 1,000 divided by 1,000, I'll get the value 1. All the fitness values will be between 0 and 1 at the moment. There's a few divide by 0 issues we could have, but I'm not going to worry about that too much right now. Okay. Another way, instead of doing, I did just realize though, here's another thing I could do. Let me go back to the rocket. This will be I think this is actually kind of useful. Why don't I, instead of doing 1 divided by distance, why don't I map that distance, which essentially has a range between 0 and like the width of the window, and give that a value all the way between width and just sort of invert that value. I guess that's kind of the same thing, but let me just do that. In this case, I might not need to normalize it. There's all sorts of possibilities. I'm just working this out. Something might go wrong, but let's try that and see how that goes. And then let me go back to the population, right? Where was that? And so now what I want to do is I want to loop through it again, and I want to get a number n, which is equal to each rocket's fitness, and I'm going to say times 100. I'm going to do that arbitrarily right now, and then I'm going to say for j equals 0, j is less than n, j plus plus. And then what I want to do is say this dot mating pool dot add, and I'm going to add this dot rockets index I. So the idea behind this bit of code right here that you've seen already if you watch my other genetic algorithms videos is that what I'm doing is I'm saying basically take the rocket's fitness, which is between 0 and 1. So, and then multiply it by 100. So I now have fitness values between 0 and 100. A rocket with a value of 100, a fitness of 100, should be in the mating pool 100 times. A rocket with a fitness value of 3 should be in the mating pool 3 times. So it still could be picked if it's only in there 3 times, but it'll be picked much more likely if it's in there 100 times. So this is what I'm doing. Line 59 should have index j. Thank you. No. This is not index j. So that's a good question, but I actually want to take rocket I and add it in multiple times. So I know that's confusing because this is a loop here, but the purpose of this loop is to take rocket I and add it in a certain number of times n. So I'm using j for that particular loop. Okay, but thank you for that question. Okay, so now I have this mating pool. Whoops, what did I just do here? Whoops, oh my god, everything's going crazy here. Sizing is off. Okay, so now I have this mating pool. Can you still see the font size? Hopefully you can. Let me know if it's too small. So the next thing that I want to do is, I'm going to write a new function for this, is natural. I'm going to call it natural. I'm just going to call it selection. I'm going to write a function called selection. And in selection, what I want to do is pick 2 parents. And so I'm going to say parent A, and I'm going to say this dot mating pool, and I want to get a random index equal. So, oh, you know what you can do in P5 now? I'm pretty sure in P5, the random function, you can actually just give it the array. This is a new feature of P5. If I just say random and then an array, it'll just give me a random element from that array. So I don't actually have to pick a random index. Yeah. So that's parent A. Now this is parent B. So I want 2 parents. And I could do something to say, oh, I want to make sure, one is not the same as the other. But, I want to make sure they're not the same. I don't pick the same twice. But I'm not too worried about that. OK. So I want to pick 2, and then I want to make a child element, and I want to make that child by saying parent A dot crossover parent B. So this is now my wish list. I want the DNA, and this is really actually not the rocket. I want, I'm going to call this child. I'll call this child. I want to have in the DNA object a function that takes, oh, you know what? This is actually, interestingly enough, parent A is a rocket object. So what I'm going to do is say .dna, because I'm going to go and grab the DNA from, I'm going to take the random rocket object and grab its DNA, because what I want to do is create child DNA. I want parent A to DNA to cross over with parent B's DNA. So that means in the DNA object, which is, there's going to be a lot of scrolling in this, right here, I need a new function, and I need that function to be called crossover. And in this function, I need to create another array, like child. I'm going to call it new DNA, is an array. And what I want to do is loop through the length of the genes, and it needs an argument partner. So the crossover function needs an argument partner. And what I want to do is I'm going to say, I'm going to make a midpoint. Midpoint equals a random number between 0 and the length of the array. So I'm actually going to pick a random midpoint. I could always pick the exact middle. But what I want to do is I want to say if I is greater than 0, I want the new DNA to come from this object's genes. Otherwise, and I want if I is greater than the midpoint. And otherwise, I want the new DNA to come from the partner's genes. And then I want to return new DNA. So what I'm doing here is I now have written a crossover function. This is going to be a long video. I have written a crossover function. We can look at it closely here, which basically says, I am a DNA object, and I have received another DNA object. I'm going to pick somewhere, and they're both arrays. So I'm going to make a new array, and then I'm going to, there's some flaws here. I'm realizing I got to fix something, but that's fine. I'm going to pick a midpoint in the length of the array, and I'm going to get half. Before the midpoint, I'm going to get these genes, and after the midpoint, I'm going to get the partner's genes. Now, there's an issue. This here is just an array, but what I really want is a DNA object. So what I want to do is actually say I want a new DNA object, and it'll make random genes when I do that, but I can, and I want to fill the genes. I'm going to overwrite that this way. I could be a little bit more elegant about how I write this, in which case I'm going to do that now. So that's one way I could do it, but I'm actually going to keep this as an array. And I'm going to call this new genes. And then what I want to do is say return new DNA. I'm going to say return a new DNA object with the new genes, which means I now can actually just give the DNA object an array rather than have it be random. And in this case, in the constructor function here, I can have a variable called genes. And I can say, if genes exists, then this .genes should be that array. Otherwise, do all this other stuff. Shift tab, pause. No, what is the, thanks Oliver, I see that there's a bug. What is the auto format for CodePen? CodePen auto format. Key. Maybe auto format. What is it? Key auto indent. Key bindings. Command tab. Oh, I could also use command that, of course. Where do I see? Tidy up code. There it is. Shift tab. Yeah, I thought I was hitting shift tab. Oh, that didn't really work. Command tab? No. All right, well, la-di-da. OCD, I know. Click on the arrow. There's a button to tidy.js. Yeah, but I need a key command for that. Oh, and look at that. I don't want it to totally send me to a new place. I don't remember where I was. Okay, hold on. So it was like this, right? All right, I'm just going to do it myself. Back. Right. So now what I'm saying here is in this function, this DNA object could either receive genes and just create a DNA object from those genes, or if it doesn't receive genes, then it could just make random DNA. So now, somebody in the chat, line 101, telling me that there's an error. Yes, this return has to come after that for loop. So that is definitely an error. OK, so now I have my crossover function done. In the population object, which is, I guess, closer to the top here, where I have selection, I now have, this is child DNA. Now what I need to do, and I want to do this how many times? I want to do this. First I want to say new population is an array. And then I want to loop through, and I'm going to say new rockets. New rockets. And I want to loop through the existing rockets. And I want to do this for every single existing, and this should say this.rockets. So now what I want to say is new rockets, index I equals a new rocket with that child DNA. So this is what I want to do. I want to have parent A pick a DNA from one parent. Parent B pick a DNA from another parent. Cross over those two DNAs and make a new rocket with that DNA. Now, does my rocket, where is the rocket object? Scrolling like crazy once again. Now the rocket object should have an optional argument. The rocket constructor should have an optional argument called DNA. So I could say, if it receives DNA, then this.DNA equals that DNA. Otherwise, it can make new random DNA. So once again, I now have rockets that can be made from DNA. It still will get the default position, velocity, and acceleration, but it can get that DNA. OK. OK, so now, maybe, OK. OK. Woo, so much going on. I'm going a little crazy. I need to calm down for a second.
So this is random.
No, that doesn't help me calm down. Oh, nice music there. OK, so let's see what we've got so far. Where am I in the population now? Now what I want to do is I have this new population, and I just want to say this.rockets is now the new rockets. So let's see if things are kind of working. In the main program now, instead of just making a new random population, what I should be able to do is say population.evaluate. And I'm sure there's going to be tons of errors here, but we'll see what happens. Population dot, I'm almost certain that I've forgotten somewhere. Population dot selection. So if I run those two things, weirdly, I'm not seeing any. Let's look in the console. Count is not defined, line 58. OK, hold on. Let's see if this console, no. I don't know, maybe that's just an old error from something. I'm not going to worry about that. This oddly seems to be working. OK, this.genes 3 times if I'm correct, says the chat. So let's look for
This dot's on.
Oops. Pause for a second. I gotta think about how I'm going to determine if this is working. Because this is a pause point in the video. I'm going to let it run for a minute. Line 97. Yep. This is also wrong. OK. Click the thank you. That's where I need to look. Hold on. Wait, where did it go? Where did the exclamation point go? Yeah, now I see where the problems are. Print the max fitness to the DOM. That's a very good idea, Dominic. So I need to fix the this.genes in a bunch of places and print the max fitness to the DOM. These are great ideas. Okay, this.partner should be partner.genes, probably. Yes, yes, it should be. Thank you. Okay. 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 Back, and I'm here to correct a few errors because I definitely have some this dot things that are wrong. So this over here should be this dot genes. This should be this dot genes dot length. And this, by the way, should not be this dot partner. It should be partner dot genes. So that wasn't working. So that sort of helps things. So there's an exclamation point here, which should be telling me unexpected token on line 41. So this dot evaluate equals a function. Okay, so let's see. That kind of helps. That was a problem. Great. So we've got an error. Let's see if I can look in the console. This dot mating pool dot add is not a function. So line 59 here. This dot mating pool. So I'm thinking in Java land where I would use an array list and it would be push. I mean, it would be add, but in JavaScript it should be push. So let's run this again. And when it gets to 200, let's see what happens. Another error. Let's see what happens. I thought I fixed that. This dot mating pool dot add 66 and 75. 66. Okay, hold on. The line numbers aren't exactly right. Let's see if I can go here. No. Pause again. See, this is my problem with using CodePen. It's not really a problem with CodePen. It's just me. Not familiar with what I'm doing. New rockets 75 is not a function. Oh, whoa. Yeah, so the line numbers are off. And it's still got old errors in there. Yeah, clearly it should not. Okay. See, this is an issue. How do people do debugging with CodePen? Because why shouldn't the console, let me just, why wouldn't the, can I run it again? Let's see, yeah, why wouldn't the console, you would think that this console would show me the errors, which it doesn't, so that's not very useful. And it's nice that this console, now I got it right. So if I refresh the page, then it picks up the correct, no, it's still wrong. It's 3 lines off. Whoa, that was a loud noise. All right, so anyway, there's a lot of pausing here. Back, so this is a problem. I don't know why I said this dot rockets equals new rockets, like new rockets was a function. No, new rockets is an array that I want to assign to the current rockets. So I'm going to do that, and let's see if we get now it running again. Okay, so it looks like we're getting a new generation, and look at that. You can see how even just that second generation, the rockets are now kind of pointing more straight up. So the ones that have kind of made it. Now there's a bunch of issues with this. Number one, I need to sort of figure out, how do I know if the genetic algorithm is working? I can kind of see loosely that it is generally working in that if I were to refresh this whole page and run it again, you can see they start all going off in random directions, and one of them happened to get quite close. And you can start to see that over time, it looks like maybe more of them are starting to go towards that target. So that array of vectors is sort of evolving towards a bunch of vectors that point straight up. So I have the sense, the general sense that this is working. Okay? But how can I really kind of understand and know if this is working well or not working well? Well, one thing I could do is just kind of find various things in my code to kind of look at. So what I want to do is create, I'm going to just say create p max fit. So every time it runs, I can kind of see what that maximum fitness value is. 363, I'm going to step to the side here, 355. So that makes sense. Like I'm getting reasonable fitness values, 366, 390. So that kind of makes sense. That's a good sign that that maximum fitness is going up from frame to frame. So something's actually working. I would be curious to know, to kind of just see the range of fitness values. So I'm going to say console log this dot rockets. Let's see if I can look in the console here while it's running. Come on, this dot rockets. Let me see that in the console, please. Does console.log not spit stuff out to the yeah, I want to use the browser console. There we go. I don't know why that wasn't coming out, but now I can see it, and I can look at all the rockets, and I can kind of see the fitness. Negative 0.36, negative 0.32. So you can see these are the normalized values. It's a little weird that I got a negative number in one of them. But fitness 1, that was the one that had the maximum fitness. So you can see the fitness values are kind of making sense. So this is a good sign. So I'm happy that I have reasonable fitness values. Hold on. Pause, sorry. I have to just take a moment here. This is very hard to do, because I'm not as familiar with CodePen. Average fitness values, negative when it goes off the screen. Yeah, so people are providing all sorts of suggestions in the chat. Going off the screen shouldn't give it a negative fitness. I believe it's getting a negative fitness if the distance is greater than width. And I'm mapping that back to reverse. Yeah. Okay, so I'm going to come back into this video. I just had to take a momentary break. Eventually there'll be an edited version of this. And what I'm going to do is improve the fitness function. Okay. Okay. It actually is kind of working quite well over time. I'm kind of surprised. Thank you, everybody. They should stop when they hit the target. That's exactly what I think I'm going to do next. Okay, everyone. Okay, I'm back. So what I want to do is I want to do some things to improve the fitness function. And one thing I just want to do is I don't want to let them go. When they hit the target, they're done. They've achieved their goal, and they should get like a super high fitness. So one of the things I'm going to do in the rocket itself is I'm going to look for the rocket, and I guess what I'll just do this in the update function. I'm going to check the distance between this particular rocket's position and the target's position. Ooh. And if that distance is less than I'm just going to say if it's less than 10 pixels, then it's reached the target. So let's say, let's create a Boolean variable here called, I added something to the code that's kind of making it stutter a little bit. But I'm going to add a variable called this.completed equals false. And when it's reached the target, I want to say this.completed equals true. And then I only want it to move if it has not completed its goal. Okay? So I only want it to update the physics engine if it hasn't completed the goal. And also, if it has completed, what I'm going to do is just say this dot position equals a copy of the target's position. So I'm just going to actually move it to the target. So this will help actually give each of these the best score possible when they hit the target. And you should see none of the rockets should now go past the target. The other thing I think is worth doing is I could say here, all right, well, if this dot completed, let's make things that have actually completed and reached the target. Let's take the fitness and multiply it by 10. I don't know if that's a good idea, but I could just say like, you know what, you're doing really well if you get close, but if you actually reach the target, your fitness is just like massively bigger. So I'm going to refresh the page. CodePen is refreshing automatically, and let this run for a little bit. I'm going to pause this video and I'm going to edit to like where it's been running for a while. So Mathieu, when you edit these together, I think you can edit this part out. And I'm just going to let this run for a little bit with some music playing. Oh, that's the run. Come on, rockets. Oh, I didn't add mutation. I realized there's no mutation. I forgot about mutation. So you can see they're evolving, right? It's working pretty well. All right. Yes. And then I also want to multiply. I also want them to, the faster they get there, have a higher fitness too. Yeah, Chris Jordan in the chat asks, why do your cameras shut off after a while? That's so weird. And it's because I haven't been I'm using these Canon 5D cameras, which turn off automatically after 30 minutes. And there's supposedly a setting where you can stop them from doing that, but I haven't been able to. Okay. And I'm back. So you can see now that after a bunch of generations, and I should add something to the DOM HTML window there to like show how many generations it's run, you can see that these rockets are now shooting directly up to the target they've evolved. So I want to add a bunch of things. One thing I might leave to you as an exercise is how could you augment the fitness function so that the faster they get to the target, the higher the fitness. So you could do something based on what is the count when it gets to the target, and that could be something that you could add to the fitness. But I just realized I didn't add mutation to this particular example, and the genetic algorithm might work a little bit better or do some more interesting things if I add mutation. So I want to go to the DNA object and add this dot mutation. This is a really easy function to add because all I need to do is say is have a loop. Whoops. Is have a loop that goes through, that has a loop that goes through all of the genes. Sorry, pause. I shouldn't just say pause all the time, making this like impossible to edit. But this computer's getting really hot. But it drives me crazy that I'm like going nuts with the environment. So I'm just going to come back. We're going to do over. Because this is what it should look like. Oh, I'm going to have to let this run for a little bit again. All right, let this run for a little bit. As always, I always forget the this dot, this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do dot, this 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 dot. Never forget this dot, this dot, this dot, this dot, this dot, son. This dot, this dot. This dot, never forget this dot, this dot, this dot, this dot. I'm going to do this dot. Come on, evolve, rockets. Okay, I think that's probably good enough.
So this is random.
Too many buttons. Okay. All right. Okay, I'm going to try this again. I'm back, and you can see that the rockets have now evolved a nice path of going towards that target. So you can see they're all actually going along the same path. Now, one thing I realized that I forgot to add to this genetic algorithm is a mutation function. So I'm going to add that right now. And I'm going to put that right here under the crossover function. Mutation is good. In a lot of cases, these rockets can now only ever have the path based on the original random vectors. So I could just write a simple function that just loops through all of their genes again. And what it does is it just picks a random number. And let's just have a mutation rate of 1%, meaning if I pick a random number less than 0.01, what I want is for that particular gene to just become a new random vector. So I'm going to pick a new random vector, and I am also going to then set its magnitude to 0.1, which I think is sort of the arbitrary length of these vectors that we've decided. So now I've added a mutation function as well, and I can, after in the population object, right here, after I call crossover, after I cross over one parent with another, I can also just say then child.mutation. And so now, if we let this run with the mutation function, we should see that mutation will play a role that ultimately, eventually, they might evolve. They'll be able to evolve an even more optimal path because, in this case, every single vector really should just point straight up, right? That would be the perfect thing for it to evolve eventually. Now, here's an exercise that you can think about adding to this. The length of time it takes for the rocket to make it to the target, that could absolutely be a part of its fitness, right? If it makes it to the target faster, what is the current value of count when it makes it to the target? That's something I could save, and the lower that count, the higher its fitness. So I might leave that as an exercise for you to add in, but what I'm going to do right now is I am going to add just a quick obstacle, because I think that will be worth it to sort of see. So let's make a rectangle in the window. Whoops. I'm going to draw a rectangle that's like start at x is 200, x at 200, y of 50. It's going to be 200 pixels across and 10 pixels high. Let me say fill 255, and it should clearly be much lower down. And maybe it should start at 100, and it should be around there. Right, so there's an obstacle for you. That's actually a pretty hard obstacle to get around. So what I want to do, and let's make these variables. Rx is, what did I say, is 100. Ry is 150. And Rw is 200. And RH is 10. So what I want to test in the rocket object, and where is my rocket? Here it is. What I want to check here is in the update function, right? This is checking has it reached the target. But let's also see if it knocks into that obstacle. If pos.x is great, okay, this.pos.x is greater than that Rx value, and this pos.x is less than Rx plus Rw, right? If it's between there, and this pos.y is greater than Ry, and this pos.y is less than the top of the rectangle plus the height, Ry plus Rh, right? In this case, I'm going to say it's dead or it crashed. This dot crashed is true. So, so I want it to stop moving if it's completed. As long as it's not completed and it's not crashed. And we can say each rocket now has a variable called this.crashed, which is also false. And then in the fitness, if this dot completed, this dot fitness times equals 10. If this dot crashed, let's just set this dot fitness equal to 1. So I'm not going to set it to 0. I probably should set it to 0. But let's set it to 1, okay? So now we should see, let's see if these rockets over time evolve to go around the obstacle. Now I'm going to pause and let it run for a while. Flooper says you need to add the vars in your obstacle. Oh yeah, thank you for that. I'm going to do that. Technically it should work without that, but to be sure. Oh, I'm going to let it run for some music, please. Yeah, I definitely need to increase the lifespan. Come on, rockets. Ooh, that one did pretty well. I think they just gotta so first of all, the forces are kind of weak and it's not very much time. So I should also do the collide with the border of the canvas. All right, fine, let's add that in. Okay, so you can see now it's been running for a little bit, but they haven't really evolved to go around the obstacle yet. So let's add a few things. Number one is they need a bit of a longer lifespan. So I'm going to let them go for 400 cycles. I also want to make them crash if they hit the edge of the window. That I think will help a little bit. So let me go to the rocket, and in this place where I'm trying to check if they've crashed, I can also check things like if this.pos.x is greater than width, or this.pos.x is less than 0, then this.crashed is also true. And I can also do the same thing with the height. So I can also have them crash if they go off the edge of the window, which I think will help. The other thing that I might consider doing is I'm going to make a global variable called max force, which is 0.1 right now. So I'm going to look for wherever I have 0.1. Right here, I always set the magnitude to 0.1. I'm going to now change that to the variable max force. And I want to set this to max force. And there we go. And now, oh, look at this. These poor rockets that start going down off the screen. It's going to take them a while to evolve out. So, I should give them all, I should give them all a little nudge up. That might be a nice thing for me to give them, but I kind of don't want to. But I am going to give them a higher maximum force, which I think will help. So I'm going to make that maximum force 0.2. Which I think, and then I also though want to limit their velocity, which I think will be helpful, just to make it so they don't sort of spiral out of control. I'm in the rocket object. I'm going to here say this.velocity.limit to 4, and now that's a bunch of things that I've added. Let me zoom in here on our rockets. And I'm going to let this run for a little bit, and I'll come back after it's run for a little bit. We'll see how it goes. Boy, all the rockets. So look, if all the rockets died. So let's see if one of them can manage. This is going to take a while. So there's a lot of things I could add to this. First of all, I could just have a lot more rockets. If one of them would just figure out not to die, not to go off the edge. They're evolving to be close to the obstacle but not to hit it. It's the thing that get the best score until they learn how to go over to the obstacle. Change the color if they crash, that would be good. I just want to let this run for a little bit. We need a... Okay. All right, so this clearly isn't going to work. Let's futz with some parameters. When they crash, just decrease their fitness a little bit. Clearly, I need to do that. Let's try that. Okay. So I've let this run for a little while, but unfortunately, all the rockets are crashing. And so the crashing just like totally ruins their fitness. And actually, the ones that crash kind of closer to the target, we kind of want to keep. So what I'm actually going to do is I'm just going to divide their fitness by 10 when they crash, and that way we still have the fitness scaled, so to speak. So let's have this run for a little bit longer and see what happens. Pause. Yeah, so those should get a much higher fitness right now, and we should get more that kind of zoom around up to the top there. There we go. Ah, yes! Hit the target. That was exciting. Now look at all of them go. There we go. I'm watching them over there. I guess I could watch them here too. Look at them. Look at them all go in this weird like dance formation. It's like smart rocket formation. Okay, I'm back. So these rockets have now successfully evolved, and you can see that one of them figured out how to get around this target and get around the obstacle and hit the target. You can see that it had some like accidental weird DNA in it that makes it go kind of like in this weird pattern, and they're all kind of doing that. So this is where if I were to add something to the fitness function that gave the ones that actually make it to the target a little bit faster, a higher fitness, they would start to work out the path so that they wouldn't be kind of doing this strange extra thing. Because as long as they make it to the target before the end of the lifespan, they're fine. So I'm going to leave this video, I think, here. There are so many improvements you could make to this. I might like to make some of them at some point or come back and do a video. You might like to make those improvements and share them with me. Number one is just design-wise. You could add color, add design to the rockets. You could create a much more interesting maze or course for them. You could create obstacle objects and allow the user to move the obstacles around, make the target movable, so they have to adapt and evolve. We could improve the fitness function in a number of ways. One, by keeping track of the amount of time to reach the target. Something that I'll talk about, I think I'll make a separate video about this, is just talking about why an exponential fitness function instead of a linear fitness function can be something that's quite useful, which you could add to this as well. Look for the next video, kind of how I do that. So those are a bunch of ideas of how you could make this system a bit better. And in fact, one thing that I will do is I'm going to revisit this example in a future video looking at how a neural network or other types of machine learning algorithms might also be used to train agents to move around the screen with a certain path. So I hope you enjoyed this rather, I think, insanely long and scattered coding challenge. The code itself will be available on both GitHub as well as a link to this pen, this CodePen that I created here. So you can actually just go straight to that link and play around with the code there as well. Okay, I hope you enjoyed it, and I'll see you in a future genetic algorithms video. Okay, so that is that. So this was like mildly successful. Yeah. Nexter Kate makes a really great suggestion in the chat and writes, can you run it 10,000 times without the graphics and then run it normally? Yes. So something really interesting to build into a system like this would be to just have the algorithm itself run the simulation without the animation loop, without drawing it. You know, JavaScript in the browser perhaps isn't the best kind of language and environment to do that in, but we could certainly number crunch it with, and then actually just like pass all that DNA off to a set of resulting objects, which would then animate. Okay, so I kind of want to add the count thing in just because I'm curious. I want to clean up the code, but I think I got to put this aside. I'm going to save this. boy, this kind of, how long have I been doing this live stream? Well, this has, when did I start? I guess I've been on for about 2 hours now. Maybe I can go a little bit longer. Think about some other things I could add here.
Cutting rainbow.
So I can just close this now, yes? Yeah, just this. Okay. All right, so I think that's pretty good for this example. Let me go back to my, let me go back to, let me go back to my the topics here. The genetic algorithms. So I suppose I did. Now I can check this one off. I don't know how long that video is going to be in the end. I mean, I was doing this for at least an hour, but there was so much of like when I kept saying pause that it'll probably edit down to. Yeah, so one thing I'm planning to do is I'm planning on in the future doing, I think the Flappy Birds game would be, is a really good example of looking at how a machine learning algorithm with something called reinforcement learning could be trained to play a game like a Flappy Birds clone effectively. And so that is something that I'm hoping to get to this summer. I'm trying to get through, so actually, let's talk about my upcoming plans for more machine learning topics. So I don't know what people are getting excited about in the chat because I'm off sync time-wise. But so let's talk about this. So I have, I'm going to give you some. So if you go to natureofcode.com and click on Read Now and go to chapter 10, there is a chapter that I wrote for this book about neural networks. This chapter was written probably 4 or 5 years ago. It doesn't go too in depth to things. It kind of talks about the general theory behind neural networks. It looks at this sort of some scenarios and examples of what neural networks are used for. And then I walk through the code for a very simple, kind of like the simplest kind of neural network called a perceptron, which is a single neuron with just two inputs and one output. And then I kind of don't really go much further than that. And I don't necessarily want to go much further than that in terms of writing code for things called these multi-layered perceptrons and yada, yada, yada. But I do want to open up possibilities for further types of applications. So the perceptron is interesting in the theory, and it's also interesting in how you would code it. But you're not going to find too many scenarios, creative scenarios, where the perceptron is actually going to help you solve a problem or create some type of strange, playful experiment. However, having a more sophisticated neural network built out of multiple perceptrons will allow you to. So I'm looking at, and so there's two things that I've been reading and researching. One is a project called Wekinator. Wekinator is software for real-time interactive machine learning. It's developed by Rebecca Fiebrink, who she is a professor at Goldsmiths in London. You can find her Cadenze course, Introduction to Machine Learning for Artists, I believe it's called, or for musicians, artists and musicians. It's right here, actually. Sign up for a free online class. I highly recommend this online class. Her videos are excellent. I've been watching them. Wekinator is awesome. It allows you to really just sort of plug and play machine learning. Like it's software that you run. So it's got a GUI interface. You can plug inputs into it. You can train it. You get outputs out of it. But I've decided I don't want to use Wekinator. I might like to make some video tutorials with Wekinator, but for the Nature of Code book and examples, I would rather have the code interface with a neural network library directly, rather than work with OSC and messaging in a separate piece of software. So yesterday, that is, I made an example using something called Neuroth, which I found. I made a quick and dirty processing library, which can use processing with this kind of neural network, and I trained it just to recognize points that are inside a circle or outside a circle, and that completely worked. So that was promising to me, and so that was something I was looking at using as a framework for having kind of an API access to neural network library and code. But then I started thinking that because of Wekinator, and actually Rebecca had this advice for me, she's been giving me some great advice and feedback, that I might actually just look at Weka directly. So Wekinator is actually built on top of something called Weka, which if this, and Weka is like a bird, I forget, it's like maybe a bird in New Zealand. I love anything that has to do with birds. Oh, I could get a Weka sound effect perhaps. So Weka is an open source library for machine learning that's written in Java. So I'm thinking actually what I would like to do is use Weka, make Weka a processing library that you can access directly. That way I can show examples that run both in Wekinator if you want to use the software interface, or that you could write the code directly for in processing. That's kind of my plan. Now, and so the other question that brings up is, well then how do I then translate these examples that I'm going to make in processing into JavaScript? So one possibility would be find sort of to just make a JavaScript library to port some of the Weka stuff to JavaScript. I'm not so sure about that yet. So if anybody has ideas or suggestions or wants to help contribute to developing an open source neural network library that could work both with processing and P5.js, I'm kind of open and game for that. Please let me know. Now, another resource that I just started reading, which is excellent, I'm about halfway through it, or maybe a quarter or a third of the way through it, is called Machine Learning for Designers. This is a free ebook from O'Reilly by Patrick Hebron. Patrick has also been emailing me and giving me some great advice about a new chapter on machine learning for the Nature of Code book. This is free. You can get a Kindle, PDF, etc. This is not going to give you practical code examples, but it's going to talk you through the current state of the art of machine learning. What are sort of like the range of libraries and possibilities and applications, and what are the different algorithms people are using? How does this apply to design and thinking about user interface design? This is a great text to sort of kind of give you a background and scope. So I'm reading that as well. So, you know, machine learning and neural networks, as much as I've done some of these basic examples, is a new topic and a new field for me. So I'm kind of in the research and development phase. And once I get a little further, I'm hoping to do this before September, because once September hits, I'm going to be busy with other stuff. Try to get some video tutorials done and more examples in this direction. Okay, so that is that. I'm also thinking about some numbers.
9, 2, 7, 6, 1, 9, 4, 8, 9, 2, 1, 3. I think 9, 1. 2, 3, 4, 3, 4.
So. Let's see, it is 1 o'clock. I plan to come back tomorrow. So I think I might need to wrap up for today. I did one coding challenge and one video, which was rather long and kind of crazy, and I used CodePen, which I really like, but I think that I think CodePen will work better in the future for smaller, shorter code, quick and dirty sketching and algorithms. For larger projects, I might want to use processing or like the Atom editor. Anybody have any other questions or things they would like me to address in this particular session today? Otherwise, I think I'm going to kind of wrap up for today. Let's look at what other interesting topics there are, kind of coming in the future, perhaps. Oop, there's a new topic that somebody posted just 8 minutes ago. I like to sort these by the thumbs up. So machine learning, the computer vision tutorials I started, I definitely have more on that list. I'll get to those at some point, I hope. Machine learning, by machine learning I really mean neural networks in this case. I haven't really gotten to. This would be a great topic. Genetic algorithms, that's what I'm working on right now. Chrome extensions will come in September. Fast forward labs, check Mario, those are great. Arguments in JS. Oh, let's do this. Let's do arguments in JS. I want to do one little more thing. Processing and Android development. Let's do this. Yeah. Okay. So I want to go by 1:30. I have somewhere to be at 3. I need to eat something. Well, that should give me enough time. So let's stick around a little longer. I'm getting a second wind. And I feel like I could actually do this one in CodePen because it's kind of a smaller idea. Let's try CodePen again. So I'm going to make a new save. I'm going to make a... Ooh, how do I make a new... new pen? Okay. I don't want I don't minimize. Minimize. I want to add. There's got to be a way that I can have. Where's the CDN? I know my camera's just shut off. Chris really doesn't want me to continue using CodePen. But now I feel like I'm going to be fine with it after all that. And this is a simple, small idea. Today's the CodePen day, right? This one's going to be no problem. There's so little code involved in this one. I'm just creating a little code in advance. Oh, right. So I got to change this to professor. No, stay, save. And this is arguments. Oh yeah, actually. Do this. Okay. Oh yeah, the one issue though, which is I do see an I do see sort of an issue with this, but which is sort of the console problem. But let's see here. Thank you, Oliver. Let me just run a little test here. Ooh, thank you. Great. So this is going to work. Okay. Okay. So this is going to be, but now my head is in front of the code. Really? You have to give me this whole crazy, hold on. Oh, I'm not in professor mode, that's why. Sorry, it won't work yet to like do this. Okay, now it should work. Whoops. Is there a way to clear the console without refreshing the page? Well, I don't know. I don't know. All right, let's give it a try. Okay. can I can clear it that way. Okay. Yeah, that's what I'm going to look at, Akash. Constructor overloads, the arguments array, that sort of thing. Okay. I just don't love my setup here. Yeah. All right, fine. There's just so little code here. I'm going to skip the CodePen thing for this one. This is a bonus anyway. So hold on. Just give me a second here. I closed that Smart Rockets thing that I had been running for so long. That's too bad. Close all this stuff. Okay, hold on. Hold on, everybody. Okay. Okay. This,
As always, I always forget the this dot, this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do dot, this dot, this dot, this dot, this dot's on this dot, this dot, this dot.
okay.
This dot, this dot.
Bonus round slot machine sound effect.
This
Yes.
dot's on this dot, this dot, this dot. Never forget this dot, this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot.
Okay, where am I?
This
Coding
dot,
Rainbow.
this dot. I'm gonna do this dot,
Smart
this dot.
Rockets.
I'm gonna do this dot, this dot, this dot.
Did I change
I'm
the
gonna
name
do
of it? Where did
this
it?
dot, this dot, this dot, this dot, this dot's on this dot, this dot, this dot. Never forget
Where is that? Ah, there it is. Okay. Overloading. I'll call it.
this dot, this dot. Never forget this dot. I'm gonna do the this dot, this dot, this dot, this dot, the this dot song. Never forget the this dot.
Okay.
Oh, that
There,
song.
my happy place. Atom editor. And overloading. And here. And I really don't need a canvas, but we'll do it anyway. Okay. Nope. Okay. Okay. And now.
Coding power.
I don't know what I'm pressing.
Coding
Rainbow. Coding power. Coding power.
Coding power.
So this is random, this is noise, Perlin noise that is, in the core.
Okay. This dot t-shirts, please. I know, right? Oh, I forgot about the t-shirts. Did I mention the t-shirts? Okay. So here we go. This is the last thing I'm going to do today. I'm going to do now a video tutorial about constructor overloading and the arguments. The arguments array. Okay. And I'm going to reset these cameras. And here we are, back. Okay. I'm ready. Yeah. Okay. Here we go. I'm like, my nose is like itching me. Maybe if I blow my nose, I will stop neurotically touching it. Okay. Hello and welcome to another P5JS JavaScript video tutorial thingy-mabob thing that I'm making. This tutorial, I'm going to cover something called the arguments array, which exists mysteriously in JavaScript, perhaps without you even knowing that it's there. What you can use it for, and this idea of overloading a function or overloading a constructor, and how do you have optional arguments to a function, all this stuff. Okay, well, what am I talking about, first of all? So let's just say today's a nice sunny, warm, beautiful day. It rained last night, a rainbow came out, and you just sat at your computer and decided, I want to program my own function called sum. And what sum is going to do is it's going to take two arguments, a and b, and it's going to say return a plus b. So it's just going to make a sum of whatever things I pass to it. So I could then say here in setup, I could say var c equals, or c equal, or whatever, value equals the sum of 5 and 15. And if I say console.log val, we should see then, if I go here, I should see 20. And I can say something like sum 2 comma 7, and I'm going to get 9, or sum negative 3 comma 7, and I'm going to get 4. So this function works. But what if I were to say this? Sum 4. Not a number. Well, let's say I wanted to be able to actually have it return just the number 4. How could I have it do that? It's getting not a number because what is the value of b in this case? If I were to say console.log b and run this again, you're going to see the value of b is undefined. Another way that I can consider undefined, if I were to ask, is undefined true or false? Undefined is actually false. So something that I could do, for example, is just say something like, if b return a plus b, otherwise return a. So in this case, I now have a function that can perform differently based on the number of arguments it gets, right? As long as it gets a second argument, return those two numbers together. If it doesn't get the second argument, right, if the b is false, simply return a. So in this case now, if I go back to the browser and I say sum 4 comma 5, I should get 9, but if I say sum 4, I'll just get 4. So we've now written a function that can optionally have a second argument. Very, very basic idea here. Now let's take this a few steps further. What if I just said sum with no arguments? Now I've got undefined again. So in this case, I could actually say if a and b, else if wait, I was going to say, if b, that means there has to be an a, right? Return a plus b. Else if a, return a, else return 0. Ooh, I made this sort of like messy and awkward and weird, but you can start to sort of see what the possibilities are. So now I'm kind of checking if I give 2 arguments, return the sum of both of those. If I have one argument, return just that one argument. If I have no arguments, return the value 0. Let's just at least make sure that works, right? So I could say sum of 4 and 5, I get 9. Sum of 4, I get 4. Sum with nothing, I get 0. So great. So this is working. But what if I now want to say sum 4, 6, 8? I still only get 10, right? 8 isn't involved. Well, guess what? Anytime you call a function in JavaScript, the arguments to that function, 4, 6, 8, those things get placed into what? An array. An array called arguments. You could just say the word arguments and suddenly you have everything in an array. Let me show you what I mean by that. If I go back to the code and I just say here, I say console.log arguments, and I say sum, sum 4, 6, 8, you can see what is the value of arguments? It's an array, 4, 6, 8. So you know what I could actually do in the case of this function? I can write a function called sum. I don't even have to name any of the arguments here. I can say there is a value at 0. I can then go through the length of the array. I starts at 0, I goes all the way up through all the arguments, val plus equals arguments index I, and then return val. This is now a function that can take any amount of things, any number of arguments, 0 arguments, 5 arguments, 10 arguments, 20 arguments, and it can loop through and add them all together. So now, here, I could say things like sum 5, and I have Oh, whoops, sorry. I think I didn't reload it. Sum 5, I have the number 5. Sum 5 comma 6, I have the number 11. Sum 5 comma 4, 3 comma 2 comma 5 comma 1 comma 10 comma 11 comma negative 5 comma 3 comma 3, 33? 68. Somebody confirm for me that that number is correct. It's going to take any number of arguments and loop through all of them. So you can think of all sorts of interesting possibilities that this might open up for you in how you write a function. I could also name those arguments too as well. So like, for example, I don't know why I want to do this, but I could name the first argument, and I could also say return val plus a. So in this case, this is a little bit weird, but if I say sum 1 comma 2, it's going to add 1 and 2 and then add 1 to it again. So I would get the number 4. A little bit silly, but you can see that you can both use that arguments array, and you could also optionally name those arguments coming in. So there's a lot of possibilities of things you can do here. Now, let me make this even, just to make this even more a little bit stranger, what if I want my function, let's say I were to create an array. So I have an array that has the values 5, 3, 6 in it. So I know I could say 5, 3, 6 with sum, and I'm going to get 19. Did I leave that weird extra plus a thing in there? I want to take that out. Run this again. I'm going to make that array. I'm going to do this 14, right? So what if I also wanted to be able to say sum array? In this case, look what it did. Something crazy happened, because it actually tried to add 0 with the array, but then it tried to make the array a string and it concatenated together. JavaScript just tried to figure something out, but this isn't what I want. I want that if you pass this function an array as its argument, that you're going to add the elements of that array. So how would I do that? Well, what I want to do is I want to check. I could put this back in A. I could say if A is an instance of array, and I think capital or like this. So this is a kind of keyword in JavaScript, instance of, that can determine what kind of argument you passed in. So you could say like, oh, well, if the function receives a string as its argument, it should act this way. But if it receives a number as its argument, it should act this way. So if A is an instance of array, and I'm actually going to call this ARR, then what I want to do is do exactly this algorithm, but instead of using the arguments array, I just want to use that actual array. So now I'm going to say array.length and add all that up, right? So if you get an array, loop through that array and return the sum of everything in that array. If you don't get an array, then loop through because there's just a sequence of numbers, then use the arguments array. So now I have like all sorts of possibilities here for how this function could perform. So now I can say, let me have sum. It still works if I give it 5, 3, and 6. Now if I make an array, 5, 3, and 6, and I say sum of that array, I should also get that same number. And if I were to say array.4 equals -1, and look at that array, whoops, I have an undefined array index 3 equals 2. And look at that array again. And let me clear it. Look at that. Look at the array. And now if I say sum array, I should get 15, which is right. 14 plus 2 is 16, minus 1 is 15. So now I have this function which can both receive an array. Now, unfortunately, I can't do this, right? I would have to write, as an exercise for yourself, if you want a tricky exercise, how could you now write this function so that it can have mixed arrays and regular numbers and still add all those things together? Okay. Yes, so in the chat, some people are saying I could use the apply function and other types of things to like put the array into the arguments array, and that's a great suggestion. Maybe I'll cover that in a separate video. But right now, I just want to look at different ways that you can have flexible arguments for a function. And this often comes up in the case of making objects, like a particle object. So let's take this a little bit further. And let's just say that this is going to be a program. And I'm just going to take this and comment it out for right now. And I'm going to say, let's say I'm writing a program with some sort of particle object. And the whole point of this particle object is that it has a position, which is a vector. And I'm going to make that vector width divided by 2, height divided by 2. And then I'm going to have a function called show, which, what does that function do? It draws a circle on the screen at that vectors x and y. And maybe fill.255. And I'm going to say here, I'm going to say var p. P is a new particle. And then p.show. Now, you can see I run this program and I get that circle appearing in the center of the window. Now let's think about all the possible ways I might want to make a particle. For example, I might want to make, and let's do this differently now. Let's say there's an array called particles. And what I'm going to do is I'm going to say particles index 0 is a new particle. And then I'm going to loop through and I'm just going to call show on all the particles in that array. So this is essentially the same program. But the reason why I want to show this to you, right, is that I want to be able to say things like this. Well, particles index 1, what if I could make a particle this way? What if I could say this? And what if I could say particles index 2 equals a new particle with that particular vector? What if I were to say this? Particles index 3 equals a new particle. Let's make this 150, 100, 100, 150. Now, I'm not so sure I really want all of these, but you could imagine an object you might be able to, in your code, you might want to make particles. And sometimes you make a particle with no object, no arguments, and it always puts it in a default location. Or you could specify the location as 2 values, an x and a y. Or you could just pass in a vector, and it would put the particle at that vector. Or maybe for some reason you were getting data from a text file and you're reading in strings. And what if you give it 2 numbers separated by a comma? How would you deal with it then? So this is what you can use. How you read how you can read the arguments into. Sorry, pause. I lost my train of thought, and this is what happens when you're doing live streaming in the heat for like hours in a row. This is the kind of scenario that can come up in many things that you might want to program. So let's see if we can get all these particles to appear on the screen. So one thing that I might do here, first of all, is let's give it 2 arguments, an x and a y. So one thing we can do is say this, and actually I'm gonna change it from having a position vector just to giving it, just right now, I'm going to change it to just having an x and a y. So one thing I could actually do that you'll see is I'm going to say this dot x equals x or 100. This dot y equals y or 100. This would cover me for these first 2 cases, right? I'm basically saying I want to take the value that comes in or some default value if it's false. And in this case, it would be false because it would be undefined. No value would come in. So let's actually say I want to make the particle at 150, 50, and we could see we should see 2 particles now, right? So this is and let me give all the okay, it doesn't really matter. The point is you can see now when the particle gets 2 arguments coming in, it uses those 2 arguments, like 150, 50. When it doesn't get those coming in, it uses 100, 100. So this is 100, 100, and this is 50, 150. That's that second particle. Okay, so those 2 cases are covered. Now what about this third case? What if I'm passing in a vector? So one thing I can do is I can say, okay, well actually, right here I can say if this dot x is an instance of a p5.vector object, then this dot x equals x dot x, and this dot y equals x dot y. Now, this is a little bit weird because I'm sort of stuck in this place of I named that first argument x. So now x is kind of this vector. I still have to call it x. So I might actually want to just use more generic names like a and b. In this case, so I can say if, and I'm not saying if this dot x. I'm saying if a is an instance of p5 vector, do this. Otherwise, go back to this other idea. So now I'm checking. I've got three possibilities. One is I've gotten a vector, or another possibility is I got nothing, or I got two separate values. And we can run this again. You can see now I have three of them. All three of those worked. And I have one last possibility, which is this string. So I can also say else if a is an instance of string, I guess. Is that right? Somebody tell me in the chat. And then I'm going to put, I need to do something here. Whoops. Oh, I'm missing a bracket. So I need to deal with this somehow. So let's just at least run this and see. Let's see, let me see if this actually works. No, so I don't want to say string. Text? No. Pause. Yeah. False. Wow, how come I don't know this? JavaScript instance of string. Oh, it's probably lowercase string, maybe? Look at that. Oh, because it's not a string object. I remember this now. It's not a string object. How do I get around this? How silly. Type of. Yeah, okay. So that's fine. I should be able to use type of. No, type of's not a thing. Is that a function? Type of equals type of s. Okay. Okay. Undefined. If type of a type of s string. I see. Or type of s. Okay. Okay. Well, I got a little off track here, but okay. Okay, I'm back. I forgot that there's a kind of a funny. Whoops. Hold on. Let me do this again. Whoops. Let me get rid of this console log. I forgot. There's a sort of funny thing with strings that I forgot about, because this if a is an instance of string is not actually checking if a is just text, but if it's an actual like fully formed string object in JavaScript. And let me just show you. This is a little bit of an aside, but it's kind of worth it since it might come up. Let's say I create var s equals test. Now, if I say s instance of string, you're going to actually see that that gives me false. But if I were to say s is a new string with the text test in it, right? It's actually like a whole string object now, and this will actually return true. But in most cases, I'm just going to be in the land of saying s equals test. Whoops. Something like this. So another function that I can use in JavaScript is type of, and I can say type of s, and I'll actually get the word string back. And so I think in this case I could say else if type of a equals string, whoops, then now let's see if that works. I'm going to run this, and you can see that came through. So since that came through, what I need to do now is say I can use like a dot split by a comma, and then I can say this dot x equals number, nums index 0, and this dot y equals number, nums index 1. So split takes something, takes the string. So let me do this actually. So s equals 100 comma 150. If I say s dot split by a comma, I'm going to get now an array with 2 strings in it. So if I say x index 0, sorry. I'm going to say var nums equals s dot split with the comma. So nums, pause. Whatever, let me just come back to here. There's some point where I switched back to here. So let's say s is 100, the numbers in a string 100 comma 150. And what I want to do is I want to say nums equals s dot split by a comma. S dot split by a comma. So now nums is just an array with 2 strings in it. And so I could say nums index 0, but that's actually not the number 100, it's the string 100. And there's lots of ways I could probably convert it, but one way is I could just do this, convert it to a number, not numbers, number. And you can see now I have the value 100. So I'm just doing that in the code here. I'm saying, if I happen to get a string, split it up by the comma, then convert those 2 numbers, and we should see then another particle at 100 comma 150. So if I now run this again, we can see now I have 4 particles. So we've now written a constructor function that takes 2 arguments. You could give it no arguments. You could give it 2 numbers. You could give it a vector. You could give it a string. And it's going to figure out how to fill in the x and y based on what it gets. So this is one just kind of small instance of that. But there's lots of other scenarios where this could come up where you want to write a function to arbitrarily handle a certain number of arguments of different types. Incidentally, if you were doing this in processing or in Java, you would just write multiple copies of the function, each with different arguments, and then handle those arguments in that. But in JavaScript, since the arguments don't have a type is not part of the signature of that function, of that method, you have to handle them with an if statement by having sort of optional flexible arguments. Okay, hopefully you found this helpful and you learned something about what the arguments array in JavaScript does and how to write a function or a constructor function that has flexible different kinds of arguments and different numbers of arguments. Thanks for watching. Goodbye. Okay. Oh yeah, that's a good, Mohammed offers a great suggestion too about how about if variable a is an instance of a particle object so it clones. What Daniel in the chat says multiple dispatch. What's multiple dispatch mean? So I think I'm definitely finished for today. I don't know. I wake up in the morning and I have this thought it's going to be good. I'm going to do a coding challenge of smart rockets. I know how that stuff works. I'll be able to whip that up and it'll be clear and make sense and I won't get lost. And then it's hot and then I get confused and then I don't know. So hopefully this was okay today. I need some confirmation. Reinforcement learning I need. I think the CodePen thing was kind of an interesting experiment, but it made it a little bit difficult for me. Before I go, I will remind you of some things. Codingrainbow.com is the website. Subscribe on YouTube. I like to have more subscribers, I think, for whatever reason. You can also support my channel by becoming a patron. I'm trying to think about more goals and things to use if I can start Patreon is a crowdfunding website of ways that I can provide more rewards or different things. Right now, there's just a private Slack channel that you get an invitation to where you can ask questions or discuss various topics. You can also sign up here at the bottom, put your email address in, and I'll send emails out for live streams. I'm hoping to do one more live stream tomorrow. This is why. After this week, I only have 2 more weeks this summer until I go away. I'm going to be away traveling for the last 2 weeks of August. So I will be on hiatus then. I am possibly I have some plans for some things I might be able to do or release while I'm on hiatus, but mostly I'm just trying to ramp up and make a lot of content now so I can kind of release it over time also in August while I'm away, so there's still some new stuff. there are only 2 days or 3 days left. If you're interested in getting one of these Coding Rainbow t-shirts, there are kid sizes available. This is the URL. Unfortunately, shipping outside of the US is particularly expensive through this website, so at some point we'll try to look into companies that make t-shirts and various things that can ship outside of the US with a little less expense involved. And I think that's it. So subscribe, like, follow me on Twitter, ask questions on Twitter if you want, @Schiffman. Thanks for watching. I'm looking in the chat to see if anybody has any. Oh, Julia and Java have multiple dispatch where 2 or more functions methods can be defined with different types of arguments. Yes, that is the case. JavaScript's a little bit yeah. JavaScript can be awkward about these things for sure. So I think, I'm trying to think if I've got anything. Yes, only intro. You did miss it all. I'm at the end now. It's 1:40. This is all. I must be getting close to 3 hours because I think I started around 10:40 or 10:45. And that's about it. So thank you all for watching. I'm gonna play my song, my goodbye music. Usually, actually, I forgot to play that underneath the URLs that I was going to show. Boy, my brain has melted. If you have any more questions, you have 2 minutes to ask them in the chat. Except for the fact that you're about 15 or 20 seconds behind, so by the time I say this, you'll only have 1.5 minutes or so. I'm planning to be back tomorrow morning around 10:30, probably the same time. That'll be the last live stream of this week. Thursday and Friday have some other things on the docket. I'm going to be working on the Nature of Code book, trying to get that machine learning chapter rewritten, trying to make this machine learning library for processing in P5 that maybe wraps Weka or some other tools, make some Wekinator examples. That stuff I'll be working on this week. I need to clean my apartment. I really need to do that. So many toys and things everywhere. It's a big problem. Will I be on the Code Newbie podcast? I was on the Code Newbie podcast. I can't remember the episode number, but it was sometime last year. I love the Code Newbie podcast. You should all definitely subscribe. I also recommend the Creative Coding podcast with Seb and Ian. Saron is amazing, who runs Code Newbie. She's given me lots of great advice, and we have some plans maybe to do, hopefully, some collaboration. Maybe I can get her in here doing a video at some point too. So we'll see about that. But the work that she's doing in Code Newbies is really fantastic. They have a great Slack too. You can join. You cannot write multiple functions with the same name in JavaScript. That is correct. Yeah. Overloading, you have to do it within the code of the function itself. Some people have said they want to make a community project. I think that's a thrilling and wonderful idea. There is a GitHub issue thread about that. I would encourage you to go and participate there. I don't have any brilliant ideas in my head about that. But I encourage you guys to kind of whip that up and stay in touch with me to figure out a way to do that. The camera went off. There's about 20 seconds left. May you have coding power and coding rainbows. Oh, that's. Don't ever forget the this dot. This dot's on. Okay. See you guys. Thanks for watching, and I'll be back tomorrow morning. This will be in an archive on YouTube at some point, and all that stuff. Okay. Goodbye. Oh.